हेलो गाइस। आज है संडे एंड दिन भर हम लोग फ्री हैं तो क्या कर सकते हैं आज मैं सोच रहा था एंड देन scrolling through Twitter I came across that many people are discussing about this cool tutorial which is out by Harkirat Singh and यहाँ पे हरकीरत जी जो हैं ये Repl.it का पूरा क्लोन बनाएंगे या that's what I heard and it has used some advanced system design principles and stuff. तो जो भी है I wanted to check that tutorial out. तो आज इस स्ट्रीम पे हम Repl.it को पूरी तरीके से रेप्लिकेट करेंगे by following the tutorial by हरकीरत सिंह एंड हरकीरत सिंह जी अगर आप ये वीडियो देख रहे हैं तो आप प्लीज़ यहाँ पे कॉपीराइट स्ट्राइक मत दीजिएगा मुझे क्योंकि मेरा टाइटल भी मिसलीडिंग नहीं है एंड मैंने टॉप ऑफ द डिस्क्रिप्शन बॉक्स आपका ओरिजिनल ट्यूटोरियल का लिंक दिया है एंड आई रियली एडमायर यू अ लॉट एंड लेट्स गेट स्टार्टेड विद द वीडियो एंड सी व्हाट द ट्यूटोरियल हैज़ टू ऑफर राइट. सो लेट्स गो. हाँ जी दे दो माइक पे लाइट अप ना बोलना बहुत कुछ तो खोली पूत swear to God this in the lake top sputty pani
split end to end. We'll kick things off with a more begin.
So सबसे पहले हम लोग क्या करेंगे. So who am I? Firstly, a little bit introduction about myself. So I consider myself a decent or a decent full stack developer. I have made around many projects like 20, 25, 30 projects. I am creating my own products right now. And also beside that I have worked with 7 different startups up till now and I'm yet to graduate. I'll graduate this summer. Beside that, so the thing is I probably have a understanding of many concepts which will be used in the video. Still Kubernetes part वाला मेरा strong नहीं है, so I'll probably have to look it up. तो देखते हैं. I'll try to skim through and skip a lot of things and try to complete the implementation as soon as possible. Also light नहीं जानी चाहिए. I don't have an inverter, तो my laptop backup is good but Wi-Fi close हो जाएगा then again that's gonna have its own problems. So सबसे पहले start करने से पहले let me prepare few things. Firstly I should charge my phone. ओके ब्लू रे से बचने के लिए ग्लासेस क्योंकि कुछ ज़्यादा ही लाइट पड़ रही है आँखों पे. बैकग्राउंड आई थिंक ठीक ही है क्योंकि बैकग्राउंड में अभी मम्मी नहीं है. लेट मी ट्रे हटाता हूँ. ट्रे की जगह हम यहाँ पे रखेंगे उकुलेले क्योंकि हमने अभी अभी ख़रीदा है इसको. तो या उकुलेले यहाँ पे बेटर लग रहा है तो लेट्स पुट इट हियर. यप्स नो मज़ा नहीं आ रहा. उकुलेले बजाया जाएगा स्ट्रीम के बीच में बिकॉज मरता क्या ना करता. लेट्स स्टार्ट इट. हाँ तो इसके पहले मम्मी मुझे चिल्लाएं एंड बुलाएं. हम लोगों को स्टार्ट करना चाहिए. लेट्स स्टार्ट इट.
Beginner friendly approach and eventually move to a more production ready advanced approach of basic coding. If you've done some data structures and algorithms, if you're able to write for loops, it should be fine. If you know Node.js,
जी हाँ हम लोग हैं लाइव. चार्ट फीड करने के लिए ओके लेट्स अरेंज दिस.
yes, it's good because most of the code we'll be writing today will be in Node.js. That said, if you want to just understand function calls, you don't need to know the syntax of Node.js. You should be fine. Even if you don't want to dive into the code, if you just want to know the system design, then the video should be fine. If you want to dive into the code, you need to know a little bit of Node, specifically JavaScript. Good to have, if your time goes by, some basic and advanced things by the end of it. What is something you can take away from the video? Number one, understanding how backend systems communicate with each other. What even is backend communication? Containerization. High level, if I'm being honest. Before we start, a big disclaimer. We'll be going through three approaches. The first approach and the third approach will be going into the depths of. The second approach, I will explain and share why I went with the final third approach and why this is a decent approach but not great. The beginner-friendly approach, the very first approach, is how I would implement it from first principles back in college. What do I mean by this? I mean, if I did not know what containers are, if I wasn't able to gauge how difficult it would be to build a platform like this, the hackathon-friendly approach I would take to build something like this, highly insecure. So basically, if you use this in an interview, you'll get rejected upfront. There are very basic things that this approach misses. But why are we going through this approach? To make sure if you've done very little coding, how should you approach this problem? How would you build intuition?
Like, I've used Repl.it. Mainly before the AI fork that जो उन लोगों ने किया है. They are very AI focused now, but before that, I know it's a program. It's a platform where you can get started. Like initially, I think I know their moat is क्योंकि कोई भी program होता है, anybody who wants to get started with programming, environment बनाने में जमाने में बहुत time लग जाता है. उसी में घंटे 2 घंटे एंड वो एक रेजिस्टेंस स्टार्ट हो जाता है इनिशियली. वो रेजिस्टेंस उससे बचने के लिए Repl.it थॉट कि यार फॉर अ बिगिनर फ्रेंडली प्लेटफॉर्म वी कैन क्रिएट इट वेयर एनीबडी कैन कम, जस्ट फ्यू क्लिक्स ऑफ अ बटन कैन क्रिएट अ प्रोजेक्ट इन एनी लैंग्वेज दे वांट without having to have that programming language locally or without having a compiler in place, local setup in place. सिर्फ that user resistance के basis पे they have made $1 billion business. So it's an interesting tool. I think let's see. I know a little bit background about Harkirat Singh ji. Ki in college time they have worked with a similar GSOC organization where they have created a code editor and things. So definitely, given that, if I try to think about it, how do I create it? Let's skip it. Let's see what. Let's try to complete the tutorial.
To building a platform like this. Good to know what's happening under the hood, which is why we're building it, and doesn't scale very well. So don't or in clouds. Basically, a platform like Scrooge, which means it's not great but not bad either. Great for a new startup because it is secure, it is scalable. There are some downsides to it, which I will come to when we use this section. But this is an approach I would take if this is the first time I'm building a platform like this, and I have to build it really quickly. I don't have the time to get into the third approach. If I feel this approach is too complicated, this one just works. Lastly, what's called the cloud native approach basically means you can run this code on any cloud. You're not restricted to something like AWS or GCP. This is a good approach. It auto scales. It is secure, and this is how I would build Repl.it today.
Okay, that sounds interesting.
Using Kubernetes. Alright. What do I think of this architecture? How did I think of this architecture? How did I arrive at this architecture when I thought of solving this problem? First principles, I've done a bit of coding, so I've thought about this randomly on nights, at least if not this big of a problem. I've thought about building something like lead code many times, which the challenges that come in building something like this are very similar to the challenges that come in building something like Repl.it. So I had been pondering on the approach for many months now. Reverse engineering Repl.it. So I spent around 3-4 hours just going through the Repl.it platform and monitoring all the requests that are going out. Specifically for Repl.it, when you go to the platform and run some code, you can actually explore their file system, explore the VM, see the processes that are running, see the mounts that they have, and you can get a lot of information as to how they might be running their systems internally. You can not do this for other websites, but for a lead code of a Repl.it, almost specifically just for a Repl.it like platform, you can actually reverse engineer it pretty well because you're allowed to run code on some of the servers. Lastly, going through the blog posts, YouTube videos, and GitHub. For a lead code of a Repl.it, almost specifically just for a Repl.it like platform, you can actually reverse engineer it pretty well because you're allowed to run code on some of the servers. Lastly, going through the blog posts, YouTube videos, and GitHub. Thankfully, they've open sourced a lot of their work. In fact, their previous approach of doing this, they now use Nix, the technology that I was talking about. But before using Nix, they used to use Docker. And this approach is actually open source on their approach of doing this. They now use Nix, the technology to Repl.it like platform. You can actually reverse engineer it pretty well because you're allowed to run code on some of the servers. Lastly, going through the blog posts, YouTube videos, and GitHub. Thankfully, they've open sourced a lot of their work. In fact, their previous approach of doing this, they now use Nix, the technology that I was talking about. But before using Nix, they used to use Docker. And this approach is actually open source on their GitHub. A bunch of other good platforms that they've open sourced is something called Rust.pty, which stands for a Rust-based implementation of pseudo terminals. All of this code basically pointed me into the direction of how they might have built systems like these. I, of course, don't have access to the code, but thankfully the team has open sourced a lot of the work, so you can actually look at their GitHub and try to figure things out. This specific project also will give you a lot of information if you want to understand how their systems are working, because this is a client for talking to their systems. So if you look at the APIs here, you can understand their systems slightly better. All right, now let's get into what we're building. Let's try to explore the platform a bit and understand what Repl.it exactly does. All right. So after you sign up or log in into Repl.it, this is what you see. You're given a button called Create Repl that lets you start an environment in any stack of your choice. For example, Python, Node.js, C, C++. If I search for React here and select a React JavaScript environment and click on Create Repl, it creates an online coding environment for me. It's basically a place where I can look at all of the files in my React project. For example, if I click on source/app.jsx, I see a app.jsx file that I can edit. This is basically a very basic React application. If I click on run over here and wait for a few seconds, the ls command, I can see all of my files somewhere else. The key thing to know here is all this code that you see here, it does exist in my browser, but it also exists on a machine somewhere else on the internet. This is me accessing that machine, and this code, this website that's also finally hosted somewhere. If I click on new tab, you will see it's hosted on the internet. It's not running locally on my machine, which comes to tell you, okay, all of this code of mine that I've been running locally over here is not actually running in my browser. It's running in some Repl.it machine in the US, in Mumbai, and I can access that machine from here. It's basically given me access to a remote machine where all of this code runs for me. More practically, if we want to understand through slides, more practically, what we're building is an online IDE for long-running backend and front-end applications. The key here being long running. When the user comes to your platform and click on this run button, until they click on stop, they want their website hosted. They want you to give them access to a shell where they can run various commands. This is slightly different from how LeetCode works, where in LeetCode, you don't necessarily need a resource for the user somewhere. You don't necessarily need to host their code somewhere. When someone comes on LeetCode and submits some code, that code reaches a LeetCode server, runs there for a few seconds, and then the user gets back a response. This server doesn't need to continuously monitor and run the code versus on a Repl.it or an online IDE that lets you run something like React or a backend Node.js server. Until this process is running, there is a VM that's running the user's code, and it's a long-running process. Node.js server.
So there has to be. Okay, this is complex actually. This is complex. हम लोगों को एक ऐसा वेबसाइट बनाना है जिसका फ्रंट एंड जो है वो एक प्रॉपर आईडी ही है. तो मे बी हम लोगों को एक आईडीई बनाना है, एक फ्रंट एंड प्रोजेक्ट विच इज़ एग्जैक्टली एन आईडीई. एंड उसके बाद वी हैव टू गिव अ सॉकेट कनेक्शन फ्रॉम दैट फ्रंट एंड प्रोजेक्ट टू सम डॉकर कंटेनर लेट्स से. और उस डॉकर कंटेनर के अंदर हमको पूरा कोड जो भी फ्रंट एंड आईडीई में हो रहा है उसको दोबारा कंपाइल एंड रन करना है, एंड थ्रू सॉकेट कनेक्शन इसको पूरा सर्व करना है फ्रंट एंड पे, so that any real-time changes made on the front end are visible on that are just propagated to the system, to the docker container, और उसके अंदर जितना भी change हो रहा है that is reflected there. Okay.
Until this process is running, there is a VM that's running the user's code, and it's a long-running process. In applications, the ability to start a fresh environment in various languages. It could be Rust, it could be Go, it could be Python, Node.js, React, whatever that specific platform supports.
Okay, so the point 3 is really impressive. Ability to auto scale servers with users.
Which, as you can see, Repl.it supports 1,000 different stacks. You need to support them. Ability to auto scale servers with users. The beginner friendly approach that we will use won't auto scale, but the goal is eventually what we build is something that can handle spikes. If there are 20 users initially and then 50 users come, your server should be able to scale up very well. Why am I talking such small numbers, 20 and 50, compared to millions that might come to a website like Swiggy? The answer is the way to scale a website like Swiggy or a simple social network is significantly different from a platform like this, where you're giving the user access to some resource for a long time. So we'll see what the challenges are that come, but auto scaling a platform like this is much harder than auto scaling a platform like a basic social networking application. Run the code in an isolated environment. The last thing that's sort of key to do here is to make sure you run the user code, you run whatever the user provides you here in an isolated environment. Let me share a small example of what I mean. As you can see, and I told you, you have access to some machine of Repl.it right now. If I run ls here, it lists.
Chair is not good. My chair is very pathetic. This is a 400 rupee chair which I bought in class 9th. So that's almost like how many years ago? 8 years ago. I really need to buy a new one.
all the commands or all the files here. If I run rm star or rm dash r star or a bunch of RNS commands here, basically the command that I ran was this. Pretty much deletes everything from the server. Only a few files are left. If I delete rm dash r src, it deletes the source folder. You can basically bonk the server of the user, run extremely bad commands here. What are these extremely bad commands? You should go back to the video that I shared initially when I went to a platform like this, ran a few commands in such a terminal, and was able to see their database secrets, things like these, which is not great. Though you have to be very sure when you're building a platform like this. It's running in a very isolated fashion. Whatever you're giving the user access to, that access is extremely restricted. That is what isolated environment over here means. All right. What we are not building is a very clean UI and things like authentication. Of course, Repl.it has 10 different things today. It lets you do AI, it lets you actually deploy your application. That's slowly becoming like a pseudo cloud provider. But we're not focusing on any of that today. We're focusing on the core mode of Repl.it, which is allowing other people to run long-running processes on their servers. With that, let's get into the requirements one more time. The user should be able to start a new environment in a selected stack. For example, they select Node.js, React, Python, whatever stack they want to work with today. They click on create Repl, and then they're taken to a coding environment like this. Over here, the user should be able to edit the code, run the code, basically do all the things that I showed you on the machine. They can add whatever Node.js code they want. For example, if you start a simple Node.js Repl, over here what is being done is I've written the code of a basic HTTP server. And if I click on run, this HTTP server should run somewhere. I should be able to access it on the internet. Very similar to the React application we made a few minutes ago. All right, these are the requirements. And we'll be taking 3 approaches to solve today's problems. A few call out in case you're a startup or suddenly someone who wants to build this very quickly and needs it yesterday. You should use an external service or a code base that does a lot of this for you. You don't have to build this in-house. In fact, for a startup, it probably might make sense to delegate a lot of this initially. It does not make sense for Repl.it because this is the core of the business. But if you're building an educational website, if you're building and whatever other use case, training website for employees, you don't necessarily need to build. So it is a great way to build intuition on how you can build systems. Like these, but do not use it in the production system. Do not use it in an interview. Why? Here is a video by me 8 months ago. I shared exactly why this is a problem, why this was a problem in a coding online coding environment like this somewhere, and how I was able to get their database secrets and delete their server and actually change their UI to say Harkirat was here by executing a few commands. So this first beginner-friendly approach is almost exactly what we were doing. So do not use this approach in production. It's a great approach to show this off in a hack. If you need this quickly built in a hackathon, when no one would use it, maybe do it. It's also very easy to understand and build an intuition for us. This is how I would build a system like this, which is why we're first going through the beginner-friendly approach. The callouts are, it is insecure remote code execution. Basically, someone can come to your website, execute very bad code, and take away your database secrets. Single server setup does not auto-scale. AIM server, so everyone is running their code, their React projects on the same machine, which can get problematic very quickly. Terminal is extremely rudimentary. The terminal that you'll finally see here that we will not be as fancy as the terminal that we just saw on Repl.it. We'll see how to optimize this in the later section. But for this beginner-friendly approach, it will be a very simple terminal. And lastly, very ugly package management. What does package management mean? Eventually, you have to support multiple stacks, right? You have to support Rust, you have to support Node.js, you have to support Golang. How we build and bring Golang code onto this machine that's going to run the user code eventually is pretty ugly in this approach. We'll see how we optimize all of this in future approaches. But for the beginner-friendly approach, these are the downsides to keep in mind. Before we start understanding the intuition and the system design,
it's hard. It's actually pretty hard, and I'm sure it's gonna cost me a lot of time today. I practically have the entire day, but I will get this done.
Of the beginner-friendly ugly approach, let's get into why building Repl.it is hard. Why is it that a system like this does not exist a lot? Repl.it is one of very few such platforms that let you do this. Why this is hard to build? And the answer is number one, remote code execution. As I told you, it's very scary to allow people all around the world to write some code and run them on your own servers. So it might feel like this is very easy, but you run into challenges like people trying to exploit your servers, running a GPU here, or running a Bitcoin mine here, or putting all their assets, files, MP4 files, movies in your machines. So you have to run a lot of checks to make sure people are not doing notorious things, because you're giving them access to your compute almost for free. If I go to this platform and click on run, I have access to one of their machines, which is not a very giving someone else access to resources like this can spiral out of control very quickly if people start to exploit your resources. The question you might have is, Harkirat, why not run this locally here? Why do we even need to send this code? Can I not run this Golang code directly in the browser in my local machine? And the answer is, your browser cannot run C++ Rust Golang code. Not technically true, it can actually run Golang code or even C++ code, but for this use case, and mostly, you'll see like 1% of the time people will use something called WebAssembly to run C++ Rust Golang code. But in an application like this, that needs to be such full stack, that needs to support every package out there, every Node.js library out there. You cannot run it in the browser. You need to run it in a machine somewhere else. Long running processes. As I said, lead code is much simpler to build compared to this, because when you're on lead code, you simply send a code base over to a server and the server runs it and responds back. That's much easier to build compared to a long running process. You send some code to a server and the server needs to run it for an hour, for 2 hours, for the complete duration of while you are here. The server needs to have some resource for you ready that you can interact with through this terminal, a website that is hosted for you until you're on this page and until you click on the stop button. That's the second reason why it's very hard to build. You are giving people resources in your server fleet, and until the person is there, you need to make sure there's some resource running on some server of yours. Shell access inside the browser. The other reason why it's the hard bit to build today would be this section right here. Okay, inside the browser, you're letting the user run commands, and not just run commands. Get autocomplete. If I go here into this shell, if I press L and press tab, I think, as you can see, it gives me suggestions. Do you mean last? Do you mean less key? Do you mean login? It's a real, terminal. It's not something pseudo that you can put together, even though that's what we do in the first section. But this, in the end, you need to build a full-fledged terminal that lets you do anything. This is also so very hard to build inside the browser, and not just inside the browser, getting access to someone else's terminal and being able to run things like these, get these pretty colors is hard to build, and it's even harder inside the browser. And lastly, file stores, which is not too difficult, but still difficult. In case of lead code, what happens? You write your code in a single file. You can just send this code, the server runs this code and responds back. On Repl.it, you can create a fully fledged project. You can have multiple files, multiple folders, folder inside folder inside folder inside file, and all of this needs to be persisted somewhere. If you leave this project and then eventually come back, you should be able to see all of these files somewhere on this browser, which means they need to exist somewhere on the internet. That's another mildly hard thing to build. Amongst all of these, this is probably the simplest thing to build. Alright, let's see how we can achieve all of these one by one using the first, I repeat, beginner friendly, but not a good approach, highly insecure, doesn't scale, has a very bad terminal. Alright, keeping all of these disclaimers in mind, let's get into the first beginner friendly approach. Alright, let's get into the system design of the beginner friendly approach. For this specific system, we have one very big monolith. For those of you who don't know what a monolith is, basically means we have a single Node.js process that is going to handle everything. I'm calling it the execution service or the execute service. Step 0.1. Before you even put this website on the internet, before you even let users access this, you need to do one thing. You need to have the base code of all stacks stored somewhere. I repeat, you need to have if someone comes and creates a base node application in my Repl.it platform, their very first code that they see here, maybe an index.js file and a package.json file, we need to have this stored somewhere. The base code base that every application starts from. For example, if I go to Repl.it here, if I click on create Repl, amongst the many Repls, let's say I select Node.js and click on create Repl, the base code that reaches here, which basically includes what all files, if you look at the left, an index.js file and a package.json file, which has some default code in it. All of this needs to be stored somewhere. We need to have the base code for every stack, React base code, Rust base code, Golang base code, somewhere in an object store. What is an object store? It's basically a place where you store MP4 files or JPEG files, or in this case, .javascript files, .package.json files, anything that is not simple text, any file, if you want to store somewhere on the internet, you store it in an object store, you do not store it in a database. For example, if you look at my Cloudflare account, this is the Cloudflare object store, and if you see Repl over here, I've put some...
एक सेकंड पापा, मैं ऑनलाइन हूँ. बताओ क्या हुआ पापा? क्या?
Basic base code over here for Node.js. If you look at it, it has an index.js file and a package.json file. You need to do this for all the stacks that you're supporting. If you're supporting both, this is the Cloudflare object store. And if you see Repl over here, if you look at my Cloudflare account, this is the Cloudflare object store. And if you see Repl over here, I've put some basic base code over here for Node.js. Yes, if you look at it, it has an index.js file and a package.json file. You need to do this for all the stacks that you're supporting. If you're supporting Golang, you have to have the base Golang stored here, so that whenever the user starts Repl, you have the base code to start from. You can copy over this folder over to the user's workspace, and that's what the user starts off from. After you've done that, after you know you've created the base code for all the stacks, is when the step 0.1 is done. This is before you actually even start coding, before you even create a platform like Repl.it. Step 0.2 is bringing all the languages that you support onto your machine. As I said, we have a single monolith called the execute server. This needs to execute Node.js servers, Node.js code for the user, Golang code for the user, React code for the user, whatever our user supports, it needs to run over here. And for that reason, you need to install all of these packages in this machine, in this execute service, so that when we write our code, when we create a server that users hit this Mac machine, this AWS server, wherever your execute server will run eventually, this is your execute server. This machine needs to have Node, Rust, and Golang in it. This is also not a good practice. Ideally, what should happen is this machine, this Mac machine, shouldn't necessarily need to install Node. You should not be running the end user's code directly here. But since this is a beginner-friendly approach, the execute service will execute foreign code directly on this machine, which is why you need to have all the dependencies for the frameworks that you support already installed. Cool. So what are the two things you need to do? Number one, on S3, store all of your base code that the user can create. Number two, in your machine where you'll be finally running your code, install all dependencies or install all the frameworks that you are advertising that your platform will support. Once you've done both of them, is when you can start to write the code for the execution service. Now, I'll be running this code locally, and as I showed you, I already have an S3 store where I've put the base Node.js code. I also have Mac Node on my machine, I have Golang installed, I have Rust installed. So I don't need to install any of these dependencies again. If you want to do the same thing locally, make sure you're installing whatever frameworks you support, which in our case, I only have Node right now. I can add more frameworks here if need be. Next up, let's look at how. So I don't need to install any of these dependencies again. If you, in your machine where you'll be finally running your code, install all dependencies. Or install all the frameworks that you are advertising that your platform will support. Once you've done both of them, is when you can start to write the code for the execution service. Now, I'll be running this code locally, and as I showed you, I already have an S3 store where I've put the base Node.js code. I also have Mac Node on my machine, I have Golang installed, I have Rust installed. So I don't need to install any of these dependencies again. If you want to do the same thing locally, make sure you're installing whatever frameworks you support, which in our case, I only have Node right now. I can add more frameworks here if need be. Next up, let's look at how does this execution service work? What all things it needs to support? What are the step-by-step things that happen when a user visits your platform? Number one, what here that you support?
I am going to
already installed. Cool. So what are the two things you need to do? Number one, on S3, store all of your base code that the user can create. Number two, in your machine where you'll be finally running your code, install all dependencies or install all the frameworks that you are advertising that your platform will support. Once you've done both of them, is when you can start to write the code for the execution service. Now, I'll be running this code locally, and as I showed you, I already have an S3 store where I've put the base Node.js code. I also have Mac. Next up, let's look at how does this execution service work? What all things it needs to support? What are the step-by-step things that happen when a user visits your platform? Number one, the user wants to create a REPL. The first thing that the user does is, if you look at the Repl.it website, the user needs to come here and click on create REPL, select a specific framework, and then click on this button. What happens when the user clicks on this button? What does your execute service need to support? When you click on this button, a request needs to go out to your execute service, which needs to start the creation of this specific new environment. What does it need to? Number one, it needs to copy over the base code that you had in your S3 over to a new location. It needs to store, okay, how someone has created a new REPL. We should copy over the base code so that this is the current code that exists on S3. I repeat, what will I do? I will take the user's, this Node.js base code and put it or copy it over to a new case. For example, if the REPL that the user created has an ID1, I will copy over that code from there over to here. The base code, which includes just the package.json and index.js, not anything else. These two I will copy over from where? From the base code folder over to another folder where all of my user code is available. If I go to Repl.it, as you can see, it has all my existing REPLs, right? It has all the existing code that I wrote 2 days ago, 3 days ago, stored somewhere else, which is why they're storing all of your code somewhere. When they're starting to create your application, in that place, you're storing just the base code, which in our case, you can just copy over from a different location. That's the first thing that this execute service needs to support. What would this endpoint be? This would be the create REPL endpoint. The user tells you, I want to initialize a new REPL, and you have to do a few things before you tell the user, I am done. Now you can proceed on to the next. Cool. Next step. When the user clicks on REPL, select the platform, clicks on create REPL, they need to be redirected to this page where
So when somebody clicks on the create REPL endpoint is an endpoint where accessing which you are going to copy the code from the object store to the execution service for that particular user.
they'll see a loading screen. If you remember, when we were here and I clicked on create REPL, it first says the REPL is booting over here, and then you finally reach this page. Why? What exactly do they mean when they say the REPL is booting? You'll see this for a long time. The REPL is booting. There's a loader over here. This says working. It doesn't let you do anything. It doesn't even know what your files are. It has just a simple loader here. Why? And the answer is, when you reach the screen, you need to say from see, I am done. Now you can proceed on to the next step. Cool. Next step. When the user clicks on REPL, select the platform, clicks on create REPL, they need to be redirected to this page where they'll see a loading screen. If you remember, when we were here and I clicked on create REPL, it first says the REPL is booting over here, and then you finally reach this page. Why? What exactly do they mean when they say the REPL is booting? You'll see this for a long time. The REPL is booting. There's a loader over here. This says working. It doesn't let you do anything. It doesn't even know what your files are. It has just a simple loader here. Why? And the answer is, when you reach the screen, you need to ask the execute service, please give me all my files. Since this is an empty project, the files are just the base code, but your browser needs to ask the execute service, bro, I'm just coming here either for the first time or for the second time, I don't know. So please find my code base and return it to me so that it can be rendered here on my screen. So for that, we initialize a WebSocket connection between this online IDE interface and the execute service. I repeat, we start a new...
Yeah, I already mentioned that this is what we should have done. And this is how it's unfolding. We are creating an IDE on the front end, which is going to allow user to access the Dockerized container over the WebSocket connection and access the isolated code which they are running inside.
New WebSocket connection, which means a persistent connection from here to here, so that I can send messages to the execute service now. Execute service can send messages back to me. Why? Because eventually, when this starts, I will start to write code, right? I will start to run commands here in the terminal. I need to send all of these to the service slowly and steadily. If I write 3 lines of code here, these 3 lines of code should reach the execute service. For that reason, we need a persistent connection between this guy and this guy, and that is the first thing we do. We initialize a persistent connection. And when we're initializing the connection, we also tell the execute service, hey, this is the REPL ID 1 that I want to access. And the execute service then now needs to hit S3, get back all the code for your REPL ID 1, and then return it back to you. So what is the first thing I do? Create a persistent connection. And while I'm creating the persistent connection, I also tell the execute service, REPL ID 1 is where I'm at. Please get me the code base of that. What does the execute service need to do next? It needs to hit S3 and copy over all the code base locally to the execute service. I repeat, the execute service needs to go to S3 and ask, hey, what exists in /code/1? If you remember, where was I storing all of my code here? If you go to REPL/1, here is where I was storing all my code. So where does the code for ID1 exist? In the location REPL/code/1. So what does the execute service need to do? Go to /code/1, copy over all the files both locally on this machine and also send them back to the user so that the user can begin to show them in the UI. Cool. There are a few nuances here. There are a few things that are happening. Let me take you through all of the gotchas when you're doing this. The client told you, give me the code for ID1. You went to S3 and you copied over the complete code, which means if there were 20 files here, you copied over all the 20 files here to your local code base. But what did you send back to the user? This is a good system design interview. Did you send back all the 20 files to the user, or did you send back something else? If you look at the code of Repl.it, If I look at create a fresh React project, click on create.
You cannot send all the 20 files. You have to probably send it more, because you have to first compile and initialize the project. Like, if suppose it's a React project, then you probably have to install the dependencies like the node underscore modules folder. So after copying the files from the S3, you need to have them compile and initialize the project on the execution service, and after that only you'll be able to create the IDE is nothing but a web interface. There are no true files on the IDE. You just have, let's say, one JavaScript file which the user can edit. Suppose the project is in Python, Rust, Golang, or anything. The user on the IDE is on the browser is just gonna have JavaScript files at the end of the day. There's no way to get past that. So if there's just JavaScript files, you're editing and making changes to those JavaScript files. All the difference, the new changes are replicated or propagated from the over the WebSocket connection. The execution service or the server, it inspects all the changes, and for all the changes which are made, recompile the project and display the output again back to the front end. Front end has no actual files of Rust or C++ files. It can't compile it, as Harkirat Ji already mentioned. Yeah.
Now the WebSocket connection is initialized. I have asked for the files, they're still loading. And then after a few seconds, the files came back. But notice something. When I click on SRC, it takes a few seconds for app.css, app.js, index.js to come here. If I open a file, it takes a few seconds before the file actually comes. What does this tell you? It tells you, you incrementally get the files from the server. You lazily get files from the server. The server doesn't immediately give you everything. It first just gives you, okay, in the root folder, there are 3 files, index.js, package.json, and then maybe a folder. And then when you click on the folder, you ask for more things, you get back more things. But in a production system, should you get all there are 100 files here, should you get all of them inside your browser? No. Should you get all of them on this computer? Yes. Why do I need all the code here? Because the user might run this, right? If they click on run, you want to run the whole project here. So you need the code completely present here. You don't need it present completely on the UI. You need it incrementally based on what screen you are in. If you're on app.css, you can ask the execute service for the contents of app.css. If you're on app.js, you can ask the execute service and give me the current app.js code. You don't need all 100 files on the UI immediately. Next up, send the file system over to the system user lazily. Step 5, let the user edit files. What happens after this? After I'm here, I will begin to change the code over here, update my application, add whatever logic I wanted to add. And all of this code base needs to reach back to both S3 and the execute service. If I write a bunch of lines of code here and then click on run, I want my front end to have all of these lines, right? So I need to send all of this over back to my machine. How do I do that? Anytime, let's say this was the original code that I had, and I added a new line of code over here. I need to send this over the WebSocket file, just the diff. I repeat, you should ideally send just the diff. Can you send the whole file again and ask the execute service, please overwrite this file? Yes. In fact, that is what we'll be writing in the code as well. But in a system design interview and in production, should you just send over the diff versus sending the whole thing, the whole file? Yes. What are the benefits of sending just the diff to the server versus telling the server, here is the completely new updated file? Benefit number 1 is you're sending less data to the backend. You're only sending one line versus sending all of these lines again. You'll overwrite the data. What is benefit number 2? Can you think of this one? There's a very nuanced benefit of when you're sending diffs to the backend versus sending the whole thing. The answer,
as I already mentioned just right now, we'll just gonna create a difference between all the difference. What you can say, whenever the user stops writing, you can consider them commits. So all of the difference between the commits, whenever the user stops writing, these commit difference is propagated from the UI or the IDE to the execution service or the server, and the server sees that, okay, these are the differences, these are the changes, and loads of the project again, hot reloading.
Says collaboration. If this editor allows multiple people to edit at the same file at the same time, which Repl.it does, if I go to Repl.it and open the same Repl in a different tab, both the people can edit the same file. I can edit app.js here, and my update comes here as well. If I was sending the complete thing to the backend, then their changes will override each other if they're writing at the same point. But if they're just sending diffs, then you can support collaboration. You can support, okay, browser number 1 will send their diff, browser number 2 will send their diff, and then you can reconcile them on the backend. Is this easy to do? Sort of. This was my GSOC project back in 2016, where there was an online ID like this, and I added.
I swear to God, I've not seen this video before, and also that I just slept for 5 hours last night, so I probably am a little low on energy. But I know Harkirat sir did this much in the Mozilla project back in his GSOC days.
Collaboration to it. It's out of scope for this video. But one of the reasons why you want to send over just the diff and not the whole file. Once this change reaches the server,
Let me think about it. Uh, okay. What are the other ways in which you can collaborate? Collaboration feature is the diff method necessary? I don't know if I should spend time on this. Let's move on. I'll just write that down and think on in my free time. Diff enables collaboration and a question mark after that so that I
In the
question
end, you are editing code here, but your changes that you're doing here are reaching the final system as well. If I do a cat of app.jsx here, which basically just prints the contents of that file on the server, you will see the changes that I'm adding here are very quickly reaching the server, did not reach, and it reached. So if I write hi there here, if I run, I see hi there here as well. So the local changes that I'm making are reaching the Repl.it server, which is why the code change that has reached there. All number one needs to be propagated here to the file system, which is what you exactly saw. Number two, slowly needs to go to S3 as well. You want if the user
slowly, not concurrently. There's no necessity for execution service to be sending the same changes to S3 on real time. If I'm building it on a Flask or Python project, I can use the after request decorator. That will make the request, and once the request is done, the server has already responded. Then after getting a respond, the front end can keep moving on, and the back end can run the after request decorator.
eventually leaves this platform, closes this window, then this VM will also stop after like a minute or two. You want the changes to be persisted in S3. So the final place where I'm storing the user's code, for example, index.js and package.json, if the user is making a change,
I knew that Repl.it has migrated to Nix, and it has a very interesting story. If the stream goes on for our entire time, then I'll probably share it.
change here. Initially, it only needs to hit and reach this file system, but eventually, before this VM lies, it should slowly be pushing code to S3 as well and backing it up, so that when the VM does die, when let's say the user leaves and the VM lies, your changes reach the final S3 location and they're permanently persisted over there. A few callouts: when you're sending data from here to S3, you should debounce it. By debouncing it, I mean if you get a lot of code changes from the user, let's say user sends you. Number two, you can also mount a directly to S3, directly to S3. So S3 gives you there's a library that basically under the hood would do the same thing, but it can let you mount a server, for example, this file system over to S3. So you don't have to write all the logic of backing it up to S3. You can just delegate it to the mounting service, which under the hood will do the same thing for you. You don't understand? Over to S3. So you don't have to write all the logic of backing it up to S3. You can just delegate it to the mounting service, which under the hood will do the same thing for you. You don't understand this part? It's fine. The first callout is important. You should debounce.
Mounting it directly to S3 so that we save our time in not creating a service which does that for us. Doesn't that actually conflicts with the definition of what we mentioned as monolith? We're probably not monolith, right? If we do that. Let's see, I don't know. I don't know what does he mean by this, but okay.
You can just delegate it to the mounting service, which under the hood will do the same thing for you. You don't understand? To S3, you should not shove every change that's coming here very quickly. Add and delete files also remains the same. If I add a new file here, if I delete the file from here,
Yeah, basically the entire Git system, no? So adding a file, deleting a file is basically modifying a new file or something, right?
here, pretty much need to do the same thing. Tell the execute service, hey, this thing has been deleted. The execute service will store that in the file system. The execute service will tell S3 to delete the specific file the user has deleted them. That's how you stay in sync across three.
I don't know why, but I have created my own Git clone. Git, not GitHub, Git clone. I made it on C++. So I don't know why, but I'm getting a feeling that this is a lot similar to that. At least this part where you're just finding the differences in new files. Let's see.
Three places. Your local browser, this has the code. Your execute server, which has all your code in the file system. And then lastly, S3, which has a copy of your code in case the VM lies down and you come back to the project after a few days. Cool. All right. Steps.
You have to version controlling on S3. Or what you can do, what I think Repl.it does, at least in the free plan, is that I don't think so, saves the previous version of user's code. They just have the most recent version. I don't know if you can revert it back to previous old versions. I can. That's a feature that you see in Notion or even Google Sheets. Suppose you accidentally made some edit, which is usually on autosave when you close the file. after a day or two, when you reopen the file, you have the option to click on that history icon and see previous versions of your document. So I think they have multiple versions stored in their S3 buckets, whatever storage object store that they're using.
6, the last step I think, is actually running the code. Now you've started a project, you've written some code, and that code exists over here in your file system. Whatever code you ran has reached the file system over here. The last thing you need to do is allow the user to run a command inside this execute service so that the user can start their front-end or back-end application. You need to allow them to click this run, but how do you do that? You, again over the WebSocket wire, can send, this is the command I need to run, npm run dev, and the execute server can execute this over here. This is just a simple Node.js server. Inside the Node.js server, you can always
You also need to stream the logs.
take a command as an input and execute that command. Should you do it? No. This is where the insecurity comes out into this picture. Insecurity, this is where the execute server can execute this over here. This is just a simple Node.js server. Inside the Node.js server, you can always take a command as an input and execute that command. Should you do it? No. This is where the insecurity comes out into this picture. Insecurity, this is where the code is not secure because you're running this command directly on this machine, which is, let's say, this execute service exists on a Mac machine. You're running npm run dev or whatever the user is sending you directly on this machine, which is what makes it insecure. But for now, in this approach, what are we doing? We are simply running whatever the code user sends us on this Mac machine, and that will start the process locally. So by the end of it, you have something running on port 3000 or wherever your front-end application is running, and you have the execute service streaming back the logs to the front-end so the user can see them here on the top.
Okay, that explains why you can't run the project like that. You have a run button specifically to run the project on Repl.it.
Cool. That's the last thing your server needs to support, which is actually allowing the user to click on the run button over here or run a command over here, for example, npm run dev, or even a command like ls. All of these are a command that you send to the backend. The backend runs that command and streams you back the logs. If you run ls, this is what you see. If you run npm run dev, this is what you see. All right. One more thing, like ls. All of these are a command that you send to the backend. The backend runs that command and streams you back the logs. If you run ls, this is what you see. If you run npm run dev, this is what you see. All right. One more thing. When you run npm run dev, you started the front end, right? If I go to update, and this is a simple React project that I have here. When I click on run, number one, something runs in the console over there. Something is executing on that machine. But number two, it is also exposing the front end somewhere, and I need to be able to see that front end, explore it. And how do you do that? Well, when you run npm run dev, this machine exposed something on port 3000, let's say. You can simply tell the user, okay, bro, please visit this website on localhost:3000. This is bad for a few reasons. I'm repeating this many times. This approach is not great, but this is a good start. Why is this bad here? You have a single execute service that is running. This is the execute service. This is running on the same Mac machine. What if two people connect to Repl.it? It's not necessarily Repl.it is restricted to a single user, right? What if I open one Repl here and then in incognito window open another Repl? Let's say both of them click on the run button. Then what will happen on my Mac machine? My Mac machine will it's a first person told me to run npm run dev. Second person told me to run npm run dev. First person took over port 3000. Second process will fail. Both the users are running code on the same machine, which is why this approach is bad. But let's say if you only had a single user, this approach works. If you had multiple users, but they were not running code on the told me to run npm run dev. First person took over port 3000, which is why this approach is bad. But let's say if you only had a single user, this approach works. If you had multiple users, but they were not running code on the same port, then you will be fine. Very soon we'll.
If you have single user, that makes application worse. If you have multiple users and people can run multiple different ports, then you'll eventually run out of ports.
See the code for this and how this actually works. That might give you a better intuition if you're confused at this point. And lastly, if the user ever disconnects,
I am so sleepy right now, but the video is really interesting. I'm sleepy because I did not sleep much last night, but the video is so interesting I just can't quit.
Close their REPL. You should just clean up resources here, which basically means wait for a bit before actually removing the folder. If I close the window right here, you shouldn't immediately remove this folder copy that you had locally. You should wait for a few more seconds, few more minutes. What if the user joins back? If they don't, then delete this from here. Flush all the changes to scat over to npm run dev over here, and that's still running. Stop. Cool. That's a high level of how you can build a system similar to this. I've already written the code for it. I'll show you what it looks like. What are the things that will sound and seem a little weird in the final code that we look at. Number one, the UI will be janky. I've already talked about that. Number two, the terminal. This is the important thing. Terminal will be very minimal, and by very minimal, I mean if I go to Repl.it and explore the terminal, as you saw, if I press L and press tab, it shows me all the suggestions. Okay, do you mean this? Do you mean this? Do you mean this? A simple input box where you can run a command npm run dev. and that gets sent to the server. When you press enter, then you get back a response from the server. Okay, this is what the output was. It doesn't yet support the terminal protocol, which is why you cannot run npm and press tab and then hope keys or out initially. That will feel a little weird. This still seems like the ground. And then in the next section, we'll see how you can make it better. Cool. The downsides of this approach before we go into the code. I've repeated this a few times. I'm going to call it out one more time. Do not share this approach in an interview. This is a bad approach. This is just a good intuition building approach. This is how it might work, of course, if there were no bad people in the world. Unfortunately, there are bad people in the world. You don't want to expose your applications like this on the internet. Number one, remote code execution is a bad thing. You're allowing people to run things natively on your machine. If someone sends you run npm run dev, you're running it here on the Mac machine or whatever Linux machine that you might be running your execute service on. So allowing other people, random people on the internet, to be able to run things on your.
So actually, what is mentioned here, we are not using, for the sake of simplicity, I think, not running anything on cloud or not running anything on EC2. Right now, for this approach, we're using our own Mac machines. We're using an S3 bucket, which Harkirat is managing through Cloudflare, and I'm going to manage through AWS. So we're going to have an object store, and beside that, we are going to run it from on our Mac machines and not any EC2 instance. Okay, let's see.
Mac machine is extremely insecure, something you shouldn't do again. The video I've already covered why this is bad and how I was able to hack a few systems in that specific website. Single server setup doesn't auto scale. The other problem with this is everyone is on the same server. Everyone is hitting my Mac only. Everyone is starting their Node.js process. As soon as 5 people start, the process will, my server will begin to die. My single server cannot support so many users. Cannot even support 5 users, let alone 50 users. Port conflict between 2 users. If 2 people run npm run dev and both the React project start to take port 3000, there will be a conflict. They won't be able to, the second person basically won't be able to run their React project. And lastly, terminal is very ad hoc and first principles. As I said, the terminal that we will build right now is very first principles. It's an input box with
first principles. Okay, I should add that word. I should actually use it more. First principles. My term is first principles. Okay. I don't know much coding. I'm just, first principles.
Where you can put a command and press enter. It will send your command to the server and give you into the code base now. Before we get there, also a few disclaimers. I'm using Node.js to keep it simple. You probably want to use something like Golang for this. The reason is it's very easy to run Docker via Golang or even Kubernetes. So that's my only call out as to what language might be good for building a system like this. I'm using Socket.io to keep it simple. As you saw, we had to initialize a WebSocket server. You can write WebSockets various ways. One way to do that in Node.js is using this library called Socket.io. You don't want to do this in the log. I'll be writing code in type. Makes it very easy, encapsulates a lot of complexity for you, which is why we're using it, just to keep it simple. I'll be writing code in TypeScript, but nothing too script, so Node.js is using this library called Socket.io. You don't want to do this in the long run either, but Socket.io API is much simpler. If you ever want to create a connection between a browser and a server, Socket.io makes it very easy, encapsulates a lot of complexity for you, which is why we're using it, just to keep it simple. I'll be writing code in TypeScript, but nothing too script, so keeping it things that you should probably have in a JavaScript project, just to keep the code very minimal, actionable, and easy to understand. Basically, try to limit the number of files that we'll be looking at. Lastly, not writing any mono repos. So if you look at the front end code and the back end project, just to keep the code very minimal, actionable, and easy to understand. Basically, try to limit the number of files that we'll be looking at. Lastly, not writing any mono repos. So if you look at the front end code and the back end code, you will see a lot of code repetition, which you should also optimize for in a better application. Should you create this a Zig-based, well-linted, 100% tested CI/CD implement system? Yes. If you're building this in the real world, you're a very big company like Repl.it, you probably want to build this, add hundreds of different cosmetic things that I'm not adding, just to keep things simple. We're limiting the scope of this tutorial, so we have lesser number of files to go through. With that, let's get to the code base before we move on to the better solution. Let's get into how I've built this first version of this application. All right. Before we proceed, one more thing. Let's introduce pseudo terminals or PTY ones. We can still do the rudimentary approach that I mentioned a few slides ago, but I think it's just easier and almost as difficult to build a pseudo terminal. So rather than having a rudimentary place where you can, run commands, let's build a proper terminal. And for that, let's understand a few concepts.
Oh my god, no more first principles terminal. I really liked that word, यार. First principles terminal तो बनाना चाहिए था अपन को.
The concept that we need to understand is something called pseudo terminals, which, as the name suggests, it is a terminal that you can create, but it's a pseudo terminal. It's not a physical terminal. It does not, exist on your machine like this. For example, here is a real terminal on my Mac, and then if I ever want to not create a real terminal but allow other people to access my machine, then I create what's called a pseudo terminal. Hopefully that makes sense, and the name is self. Explanatory. If you've ever tried RDP, if you've ever tried TeamViewer in Windows where you're trying to access your friend's machine, pretty similar. Only create what's called a P. If you've ever tried TeamViewer terminal, hopefully that makes sense, and the name is self-explanatory. If you've ever tried RDP, if you've ever tried TeamViewer in Windows where you're trying to access your friend's machine, pretty similar. Only you don't get GUI access, you get like terminal access to that specific machine, which is exactly what we want. What you can do is create a pseudo terminal that your browser can talk to. What you can do if you want to ever, expose your machine over the internet so that other people can, visit and run commands on it, you can create a pseudo terminal and then stream keystrokes from someone else to your machine in that pseudo terminal, and then, send them responses back so that they can understand it. That's basically what a pseudo terminal is. If you ever want to, create a terminal inside the browser, which is the thing that you see here. This is a browser instance and you see a terminal inside. If you ever want to do this, pseudo terminals are probably the way to go. Extern.js, this library that I repeat, so that you see a terminal-like interface, and whatever you type over here, it converts it into the format that a terminal can understand. Then you can forward this to your backend server, and you run this inside a pseudo terminal, then get back the data from the pseudo terminal, give it to extern here, which will render the keystrokes that the server responded back with. That's what a pseudo terminal is. What is extern? The library that you use on the front end to talk to pseudo terminals. The old approach that I suggested that you can run in your browser, if you ever want to do this, pseudo terminals are probably the way to go. Extern.js, this library that you see on the right, is a library that lets you fetch and forward keystrokes to a pseudo terminal that you can spawn on your server. I repeat, extern.js is just a client-side library. This thing is just a client-side library that you can run in your browser so that you see a terminal-like interface, and whatever you type over here, it converts it into the format that a terminal can understand. Then you can forward this to your backend server, and you run this inside a pseudo terminal, then get back the data from the pseudo terminal, give it to extern here, which will render the keystrokes that the server responded back with. That's what a pseudo terminal is. What is extern? The library that you use on the front end to talk. Your input works like this. You write npm dev ls whatever inside, you press enter. This command goes in a single go to the server execs that specific command and then responds back with either all the logs together in the process exits immediately, or it streams the logs from the server and you can put them on input logs. Literally, as you can see, like not even close to selling, and hence let's build a real terminal. For that, now what we will do is when the person comes to our website and creates a new shell, this is the way to create a new shell in Repl.it. We won't necessarily have such a clean UI, but you get the idea. In our UI, there will be a button, and when the user clicks that button to create a shell, we'll send a command to the backend server, send some data to the backend server, and ask it to create a pseudo terminal. This backend server will then create a pseudo terminal. How does the backend server create a pseudo terminal?
So we can have a new endpoint for that. Whenever somebody clicks the shell thing on the front end, we can just simply create, we can have an endpoint will be, a request will be sent to the endpoint, which is going to create a new terminal, new pseudo terminal, and stream the logs from there. And whatever changes are made on the front end, on the IDE side, all these changes will be replicated as they are to the pseudo terminal. From the pseudo terminal, nothing gets executed directly on your machine. It gets executed via an actual terminal. So this transfer of commands from the pseudo terminal to the actual terminal, that is done. Maybe not instantly, but after a check, we can add a check there to see if malicious code has been malicious command has been sent or something which is damaging to our own systems or anything.
Implementations of creating pseudo terminals that can talk to your machine. One of them is the one that we saw a few slides ago that Repl.it has open source themselves. So we can use that, or there's a common implementation in Node.js called Node.pty. You can use either one of these to start a terminal in your backend. And once that is done, all you have to do is relay data from this browser to the PTY. and get the data back from the physical terminal to the browser. So you can write some basic code and open a terminal with node pty. You can use either one of these, data back from the physical terminal backend. And once that is done, all you have to do is relay data from this browser to the pty and get the data back from the physical terminal to the browser. So you can write some basic code and open a terminal on the browser. How? By using the external library. And this library, whenever you start to type inside, let's say, that is done, all you have to do is relay data from this browser to the pty and get the data back from the physical terminal to the browser. So you can write some basic code and open a terminal on the browser. How? By using the external library. And this library, whenever you start to type inside, let's say you type, this is incorrect, but if let's say you type ls here, it will convert them into some format that your PST understands. You send that to the backend, forward it to the PST. This PST might respond back with all of this response. If you are an ls, this is
just what I said, just what I mentioned.
What you get back. And then you can forward that to external.js again, which will render them inside the terminal. That's a high level of how we create a terminal. If you want to see the implementation attack, this is my 4 of and also 20 lines of code. It's this right here. How we create a terminal. If you want to see the implementation attack copied out of code from less than like 20 lines of code, it's this right here. It's this project on GitHub called xterm.io. This is my 4 of knowledge project by this person. It gives a very simple implementation of how you can create a browser terminal that talks to your machine. All the server code resides in this one. As you can see, it's less than 37 lines of code. We'll go through this very soon. All the client-side code resides. So it does reside, I think, client.js. Yeah, here. So yeah, we'll go through this very soon. But that's how you can create a terminal to your backend server, which is exactly what people want in a website like Repl.it. So yeah, that's high level. Let's get into the coding bit now. Alright, let's get into the coding bit. Before that, let me show you a quick demo. So if you look at what we have in front of us, is a website where you can go. It gives you a random ID. You can also change the ID if need be, and you can select an environment. We have Node and Python right now. Let's start something inside Python. And as you can see, that's pretty quick. It has a basic main.py file. If I type something here, I can actually run it. And same for Node.js. So if I go back to the landing page and select a Node.js environment, give it a random name, and you can start, it copies over code from S3, has a basic place in S3 where my code is. And then when I reach this place, it gives me all that boilerplate code. If I change any of the code right here, it reaches my machine. If I now run cat, whatever, index.js here, the change that I made here has reached here, also reached S3. And then if I run npm install, which will actually bring the node modules folder here, and then node index.js, if I click on see output, I see the final output here, which is hello. If I change this to hello world, and then rerun node index.js and click on see output, it says hello world, so on and so forth. What is the problem here? The problem is,
I'm really sleepy. But I can't stop. I can stop not. Let us see if I even have some users or not. मतलब कोई viewer है मेरा? Stop. I can stop not. Okay, nobody's watching. Stop. I can stop not. Nobody's fucking watching. Nobody's on the chat. Nobody commented. Nobody. क्योंकि कोई नहीं है जो साथ देगा बाद में कोई नहीं है.
This is my machine. I don't want anyone to come and be able to explore my file system, look at
कहानी सुनने का शौक था.
secrets, pictures, anything. The top world, and then rerun node index.js and click on see output. It says hello world. So that a Node.js environment, give it a random name. And you can start, it copies over code from S3, has a basic.
Bhai, I have to take a break. I'm really sorry. But this is so against my principles. But guys, ऐसे तो हो जाएगा. I can watch the whole video. But I think मुझे सोना चाहिए. मैं कल रात को पापा मम्मी के साथ बाहर था. घर आया 12:30 बजे सोया. जिम कर लिया गलती से. कल फर्स्ट डे था. आज तो संडे हो गया तो छुट्टी है. कल और करूँगा जिम. आई थिंक सोया 4-5 घंटे ही हूँ. सुबह उठ के नहा धो के शर्ट पहनी सो यहाँ पे कोड कर रहा हूँ. आई थिंक आई शुड एक छोटी सी नैप हो जाती ना. एक छोटी सी नैप हो जाती ना, मज़ा आ जाता. बेड आपको दिख ही रहा होगा पीछे. बुला रहा है मुझे जाना पड़ेगा. पार्ट 2 अभी 1 घंटे से बनाऊंगा. तब तक के लिए